Okay, Dr. Tommerdahl, are you ready for an unscripted, grumpy science session?
I don't know. Should we talk about what we're going to talk about, or just?
Yeah, we'll talk about it now. I like
now?
To talk about
okay.
It. I like to talk about we like to prepare as we're actually recording.
Yeah, I like to say we take at least 8 minutes to prepare to actually do a 10-minute video.
And that includes turning the computer on and logging on. So,
yeah.
Full disclosure, I did do a little bit of artwork before today's discussion.
More full disclosure, Bob had a stroke. So
you might not know it, but I had a stroke.
Yeah, it changed all our schedules to the point where I was getting out of faculty meetings because Bob had a stroke.
It's a great excuse. He can't go to a meeting because Bob had a stroke. Well, I think I'm recovering. At least I feel that way.
And so we had one or two people request that we make another video.
We had several because Mark and I just returned from the ACIM meeting in Orlando, where we have lots of friends and colleagues, and many people came up and said, "Hey, when are you going to do the next video?" And I said, "Leave me alone. I'm grumpy, right?" And I've been having fun, but we do this video for fun. The last thing that a grumpy person wants, the most irritating thing, is when you're having fun. So
yeah.
It irritates us. Anyway, so
we're never happy.
Never happy, right, exactly. And some people don't seem to get this. They're like, what are you so grumpy about all the time?
But, one of the things to be grumpy about, we were at this alternative integrative medicine meeting where a lot of people are very much used to proposing new ideas and not necessarily being in the mainstream medical world. And so sort of analogous to that, there was a paper that came out recently, which is kind of long. I had to read it. It was in Physics World or something.
Oh, this is a beautiful one. Yeah.
Yeah.
I'm a physics nerd, so I was reading through, what's going on with dark matter and everything like that, not really relevant to medical science. And I ran across a paper, and it was actually published, I believe it's in an economics journal.
It was in a physics,
economics
guys wrote
cited
it and put it in a physics journal.
Right, exactly. Okay, so, all right, well, that's what I get for having a stroke. I forget details, right?
Yeah.
But anyway, the title of the paper is, Does Science Advance One Funeral at a Time? And I can actually answer that, even though it sounds like a rhetorical question. It's not. It turns out you can prove that that's the case. And the point here is that oftentimes in fields of science, they're dominated by a few people who sit on editorial boards and study sections, and they basically block any kind of progress. They don't let people get published. They don't let people get funding unless they are in agreement with their scientific views.
No, you mean they're not unscrupulous?
Absolutely. It's what I would characterize as a form of scientific misconduct, right?
Yeah.
It's like literally suppressing alternative views of things.
I think we both had experience with it. And I think the Science Advance One Funeral at a Time was sort of a slogan that people talked about. And it was never proven. Nobody ever did this.
This is sort of like a water cooler sort of complaint. People always say, I can't get this published. You've told me this 3 or 4 times.
Yeah, there were several times something like this happened. 15 years ago, many years ago.
Before you had your stroke?
Before I had my stroke, we put out a paper that I thought was really, really good. I actually still think it's pretty good. But there was this so-called star of the field. Everybody said, no, he's the guy in charge. And actually what we had submitted was a paper based on scientific data collected from inside the brain. Okay? This guy was an armchair psychologist.
Oh, God.
And he said he had come up with a way for how he thought things worked, and we kind of disproved 40 years of his papers.
You didn't kind of disprove it.
Okay,
you flatly
disproved it. Flatly, flatulently.
He's being conservative. He's like, the guy was just wrong.
Anyway, also submit the paper. He makes sure and reviews it. After he makes sure it doesn't get published.
I know the
name.
He
chased to the next journal. And he went to the next journal.
Don't say it.
Don't say the name.
Don't say the name.
Well, we'll just refer to him as Professor Know-It-All.
Professor Know-It-All, right.
But he chased that paper, and finally on the last journal that we submitted to, after 5 years, 5 years of telling us everything that we were saying was wrong and saying, well, you have to do this to prove that. You have to do this. We did every single thing he said, and we proved it. Proved every single thing. Well, it got published.
Yeah, exactly. And
Yeah.
you know, so the guy dies, and then all of a
The guy
sudden
actually
there's
died
this
a couple of weeks after it got published.
There's this flood of new information and new ideas and new papers, and people in science know this is true. And in fact, I was working in a laboratory. I've seen it from the other side. I've seen it from the evil side because
he was evil.
Well, because
Is that
I'm
what you're
fundamentally evil. You know, back when I was in evil school, all right, and my advisor was like this, and he was an old boy who sat on every scientific review session, you know, at panel at NIH for our area of research, and he was editor or ad hoc editor on at least 8 or 10 journals.
So you call him a super denier. Any new data, he denies it.
And he had a hypothesis about why it was that old people had so much trouble falling and old muscles and aging. He had a hypothesis about how that worked, and it was based on about, you know, a couple decades worth of data that he had been collecting, at least 10 or 12 years worth of data that he'd been collecting. And it turns out that he would blackball any contrary data. So if you put in a grant proposal that said, well, no, actually, I can prove that this is not the right idea, and here's some more data that sort of points us in the right direction, boom, he'd say nope. And you don't have to have too many negatives. In fact, you only need one negative opinion on a grant to blackball it in a study section. You give it
You have to have pretty much perfect score.
You have to have a perfect score. So one person in a scientific study section at NIH can really, and you know, I'm sure I'll get a lot of hate mail for this, but that's a fact, can torpedo an otherwise very good proposal. And that's exactly what this guy did. How do I know this? Because he would come back from these study sections and he would be drinking beers on happy hour, and he would tell me this, exactly what I just said. Oh, this guy doesn't really know what he's talking about, so I went ahead and said, you know, a bunch of bad things about him. And then this person would be trying, you know, because he's never published any papers on it, he can't prove it. But then he sits on editorial boards for, you know, journals, and he blocks this guy's papers, you know, these people's papers. And it was a lot of people. And then one year, for health reasons, he wasn't able to sit on a review panel at NIH. And then when we put our grant in, there was this overwhelming flood. There was like 20 years of rage. You could see it in the reviews. It was like, finally, we get to say the truth. Somehow this guy's moved out of the way, and finally we get to say the truth. So I am telling you, firsthand evidence on the evil side of this whole equation. I have seen it happen, and I've been on the blunt end of it too, where important work that I've been trying to publish for a long time just keeps getting blocked. And you literally have to wait for people to die. So we sit around as scientists and we complain about this all the time, even though nobody ever talks about it. But finally, someone actually measured it, and it's a real paper now. Does science advance one funeral at a time? And I'm going to put a link to this paper right there. And if you are interested in why science is taking 20 years to figure something out instead of what it should take, which is like more like 1 or 2 to figure out something really important, right, you will understand.
So full disclosure, though.
What, you're evil too?
Yeah, that too.
Okay, well, at least I'm in good company.
We read we read the original paper, but then we sort of
Yeah,
it.
you know,
it's a lot of, we can't talk about that. That's a lot of work. And then somebody else wrote an article on that paper.
Oh yeah, this
so
is
we're
really
not
circulating around.
You're getting a third derivative.
This is yeah, exactly. So we were going to write a paper about somebody who wrote a paper about about the original work here, because we're sort of like third order angry about this, right? But this is really circulating around science now, and you're seeing it come up all the time on the internet. So I want, you know, anybody who's, you know, both of you who are following Grumpy Science, I think that they're both still alive. You'll be right at the front end of this wave of outrage that seems to be bubbling up among scientists. And what does it look like? Well, we did something we've never done before. We went ahead and prepared a drawing before we present it. So going to our multimedia, you know, multimedia command and control center. Yeah, we just sort of drew it out for you. Professor Know-It-All.
We're pretending Professor Know-It-All.
Idiot Technical University, or whatever that stood for.
Well, we're pretending he died.
Yeah, let's just pretend that we murdered Professor Know-It-All, which we regularly do here on Grumpy Science. Let's just assume he really died. So what does this graph mean? So this is the number of publications, and this is time, okay, in years. So this is about a 10-year span. So they looked at, I believe the number was 432 prominent scholars. It wasn't one or two. This is like looking at science as a whole, 432, okay? And they were looking at the publication rate for prominent scientists. And as they start to get kind of sick in their last year or two, their publication rate drops to, you know, sort of...
well, this isn't just the prominent scientists. This is the people on their team. This is their
Right.
collaborators.
Right.
So these actually are people in their group of thinking. In other words, a lot of people, they're not just like in the lab that are writing with them. These are people that are collaborators around the globe.
All around the globe. So this is people that are being promoted by a prominent scientist, somebody leading the field, and they're looking at 430 or so
Yeah, and
cases.
as long as you don't run against them, you can keep getting your
Right.
publications
So this is publication rate. So this is like, you know, how much it changes. You know, is it going up? So like a positive number here means they're increasing more and more publications, right? This little skull and crossbones here, Davy Jones' locker, that's the time of death of the prominent scholar. That's a funeral, okay? So their rate of publication, you know, drops to zero, and then they start publishing fewer and fewer papers until, to the point after about 10 years, the rate of publications have dropped almost to nothing, of not just them, because of course they're dead, right? I mean, I plan on publishing a few things after my funeral, but...
I'll have my best work after that.
Yeah, all of mine's going to come after posthumously, but after their death, this line really represents, you know, the papers they had in process and the ones that are being published by, you know, there's all this momentum. It takes time
People
to
at the
grind
same,
down.
people
All
trying to
their
publish the same
collaborators.
ideas. Like, let's say, you know,
It's
the
their
guys-
ideas. That's a good point.
Yeah.
This is their ideas, and they're propping them up with using their
political influence
Political
to prop up
influence
the
and
ideas.
their
All of a sudden,
power.
it's gone.
They're propping up these ideas, and I've seen this happen many times where elderly scholars are they spend the last 10 or 15 or 20 years of their career, you know, cultivating their legacy. You know, they want to really ram it home. So like, you know, like all other falsehoods, you know, the more times you repeat it.
Bah humbug.
Yeah,
we don't like new
the
ideas.
more- yeah,
so
Yeah, well, I don't like any ideas.
Yeah.
Just stop talking to me about them. But these guys, you know, their publication rate goes negative after this person's death. And this represents, like I said, like 400 prominent scholars and all the people that agree with them. And that's the green line. Well, what happens to all the people that were trying to say something to the contrary? Well, you can't see it really here because it's a blue line over the black axis. And they're trying to publish, and their publication rate never increases because they're being suppressed. They're being suppressed until all of a sudden, the guy that's holding them back goes underground.
So, you know, right after that 5-year period that I was getting that one paper published, and shortly after that, the guy that was blocking it died. We published 10 papers in 6 months.
Yeah, I've actually done this in tissue engineering. I published, I think, 20 or so papers in a whole area of tissue engineering, muscle tissue engineering, as soon as, now this guy didn't have to die. What he did
Pissed everybody
was
off.
he got everybody so angry that he had to take himself and his wife on a boat, and they tried to sail around the world. So he just more or less checked out.
Did his boat sink?
No, it got caught in a storm and broke his wife's leg, and so he had to sail back after he'd gone 1,000 miles or so. So yeah, anyway, he was checked out, and my publication rate went.
Yeah, there's something about sailboats because I know another guy who was like this, and he retired, went on a sailboat, and just sold everything. Disappeared. Actually, his boat sank.
Yeah, he's
And
probably
publications
waxing
went down, too.
surfboards in the Caribbean or something like that. So anyway, this blue line, these are people trying to break out. You know, what the blue line represents is people from outside the field with new ideas. So we tend to think of science as, hey, you got a new idea, you know, it's a level playing field, and you got a new idea, let's take some data, let's run some critical hypothesis tests, and all the best stuff will float to the top. That's true after about a decade or two.
Yeah.
Right?
And so there's a couple other things to think about. It's like, one is diversity is good. Diversity of ideas is good. And that's what's getting suppressed here. So also you got all these ideas bubbling along, and all these people are pissed, and then all of a sudden they start getting published.
Right.
And so that's really good. and some other things, but I seem to be having a stroke.
He's having some kind of
a little mini stroke.
transient ischemic event here, but I can tell you that the point of our discussion here is that science should be advancing, as it does in technology year on year. So in technology, you'll have companies that try to do the same thing. Companies try to do the same thing by getting patents and monopolies and suppressing their competition. In fact, 3/4 of all patents in the United States are what they call blocking patents to prevent people from bringing new ideas forward. And yet we see this exponential growth in the rate in technology advancement, right? Because it's a global thing, and U.S. patents don't necessarily work in China and in
this actually does go in parallel with basically online proliferation of online publishing.
So that's what I was getting at.
Before, well, the death mark here on that would be when all of a sudden one of the lead publishers, who is print only, lost their grip on everyone, and all of a sudden they started complaining and saying, "Oh, these online journals are no good." Actually, the online journals are some of the best.
Some of the best, and some of the online journals that do not have really stodgy sort of peer review that's controlled by one or two people. Those are the papers you want to start to look at, and some of them are not well done because they're not well, edited, but many of them are actually very good, and they're presenting new ideas. So I think we're going to see an end to this. What I was getting at is that in the private sector, good ideas bubble to the top because of the way markets work. If you're trying to sell buggy whips and somebody comes along selling automobiles, you're eventually going to lose market share. But in science, that's not the way that it's been for many decades. For many decades, science has been really held back by the few people at the top. Not all of them. Many of them are excellent, and they're very, very supportive of new ideas. We're talking about a few people, but they do a lot of damage to a lot of very important fields like tissue engineering, pain research, cancer research. There's definitely people at the tops of these kinds of fields that are holding us back, not months or years. We're talking about decades.
You can pick a lot of fields, and you can see where people are doing the exact same thing, exact same studies they were doing 15 years ago. With no changes whatsoever, and they still get funded because they're part of that group that everybody's.
You see it, for example, in my field, tissue engineering, my X field that I'm no longer publishing because it just didn't feel to me like it was making any positive impact on humanity. So you see these always the same thing, slightly smearing lipstick on the pig a little bit, but it's the same pig going to market over and over and over, year after year, decade after decade, and this is the explanation for it. This is something that people have been complaining about ever since I was in graduate school, 30 years ago, and it is real. The suppression of new ideas by legacy mongering, boys.
We're having a little trouble with our own paper right now.
Oh yeah. Do you want to?
So
we did a
little bit, of course. We did a little bit of robotics testing. Keep in mind, robotics. We use robotics testing to test and compare the brain gauge.
I didn't think we were going to cover this because it hasn't been published yet. When it is, I'll add a link to this video.
But it got rejected by an editor in 15 minutes because he looked at the robotics testing, which compared the accuracy of the brain gauge to other methods, which showed that accuracy was about 1,000 times better. But he complained, and he said, "You're not taking into account gender in your robotics testing."
Gosh, do you mind if I elaborate on this a little bit, just so that people can follow it? They're not scratching their head. What are these two wackos talking about? What Mark's talking about is measuring reaction time. How long does it take you to, you see it or you hear, you feel a signal, and then you click a button or something like that? Reaction time. It turns out this has been measured for what,
150, about 200, getting close to 200 years now.
People have been measuring this long before computers, long before really the proliferation of electronics at all. And it can be measured physically by very simple means, dropping a ruler and grabbing it, that kind of thing, right? So and they're always coming out with the same number, about 200 milliseconds, right? And then starting in the 1970s, everybody's reaction time goes up 300, 400, 500, and sometimes it's over a second to react, like stimulus. Oh, I reacted, right? if your reaction time was really that long, there'd be an awful lot of automobile accidents. So it's not real. I mean, anybody who really looks at this would go, no, that's not right. And yet there are, and I don't
published papers with over 1 second for the reaction time.
I don't think I know you're going to hate me for this, but I don't think I'm overstating it. But there are many, many hundreds or thousands of papers that at least have some amount of this kind of error in them. And the error, it turns out, is that people are using computers the wrong way. They're using a computer, like commodity hardware, like a mouse or a touch screen, to measure reaction time. But baked into that is all the overhead from the operating system, and if it's online. And so if you've ever taken any kind of online cognitive test where they're measuring your reaction time or reaction time variability, the numbers are wrong. I mean, I don't know how else to put it.
Yeah.
Right? So anyway,
Probably.
Mark's story is we tried to publish this. Hey, there's a problem here. So Mark and his people in this office built a robot, and they were actually measuring how quickly a robot would respond on these various devices, a robot clicking a mouse and so forth. And the paper got rejected on the basis of?
Did not take into account gender.
Of the robot. So female robots might be...
Well, we didn't specify what gender
we just assumed that robots were gender neutral, and we didn't discuss that. So...
But generally, the accuracy of the brain gauge was 0.3 milliseconds, 0.3 of a millisecond, compared to
like
400 milliseconds.
So it's like
an extra 400 milliseconds for something like an iPad.
When you build a scientific instrument and you build it, calibrate it, characterize it properly, it can be easily 1,000 times, well, not too easily, but readily 1,000 times better than what you buy at a big box store or online when you're buying a $14 computer mouse. They're very different things, and science requires us, understanding how precise your instrumentation is. So we did this in a neutral way, and the paper was rejected ostensibly because we didn't discuss the effect of female robots. I believe
this was an editorial rejection. Normally, an editor takes a paper, he sends it out for review, and then evaluates the reviews. But this guy, the editor said, no, we're not going to do it.
So maybe I'm speaking a little too much here, but that's what grumpy science is for,
it's
right? It's my belief, and I believe Mark agrees with me on this, that it was rejected because it's just a hot potato. It's just what we're talking about here. There's this large number of people who believe that, and there's this huge body of scientific research based upon measuring people's reaction times. And for the last 50 years, it's largely
garbage.
Garbage.
So we've got huge, and in this case, it's not just an idea, it's systematically being used all the time.
You see,
and it's wrong.
So the reaction time is something that everybody who's watching this, both of you, can understand. Reaction time is something simple to measure. But the same thing happens over and over again with very subtle and nuanced measurements, difficult measurements, where somebody, is controlling the scientific literature. In this case, it's my opinion that the editor simply did not want to publish a paper of this kind because it would invalidate 50 years worth of reaction time data.
Pretty much.
And so
now we think it's percolating through another journal now.
we think it is. Well, it's percolating because your first pass was, well, none of the editors really feel like they have the expertise to. You don't hear that in the type of journal we sent it to, or Mark sent it to. What that means is none of the editors want to touch it, right? Because it's one of these hot button issues. And why is it a hot button issue? Because there's a lot of people who have a lot of influence who would take umbrage to somebody saying all your work's wrong.
Put it into context. Some of the reaction time papers, or some of the papers that had reaction time data that was so bad, it showed not just really slow reaction times, it showed that people with concussion perform better than people without a concussion. So when you see that in more than one paper, and people try to blame it on some esoteric reason.
Well, they're building up these esoteric hypotheses of, well, maybe this is happening in the brain, and the other thing was they were saying that people are getting stupider.
Oh yeah, another group said, oh look, reaction times are getting slower.
Modern humans are getting dumber and less,
And then rather than evaluating that part of it, that side of things about what's going on, Then the follow-up paper was no. The next people said no. We measured IQs, and no,
Right,
IQs aren't getting worse.
They're
actually getting a little better, but
they do with every generation.
They're just getting dumber about the way they do experiments.
Turns out that there's 50 years of bad reaction time data that's
Yeah.
pervasive and dominates the literature.
And actually, it dominates the concussion literature worse than the other things
because
of the people that are play
Right.
dominant roles in that.
And the fact that it's a very important measure for concussion.
Yeah.
And it's been wrong for the entire time that concussion has been a real issue in recently, the last 20 years or so. So anyway, that is something that's provable. It's no longer just a water cooler topic of grumpy discussion. It's an actual fact. Science only advances funeral by funeral. This has been demonstrated for looking at hundreds of prominent researchers in a bunch of fields, and I feel that it's probably much worse in certain medical fields than it is in the physical sciences.
Yep.
So there we go.
That's
okay.
probably long enough.
Well, I will remember this video, and I will make sure that as we get, it's more than long enough, that as we get negative feedback, go ahead and lambaste us, right?
we don't get that many negative.
We actually do, yes.
We don't get that many negative comments, but we talked about the reaction time thing before, and we got negative feedback on that because Bob had said, well, you can go out and buy the most expensive computer, consumer grade computer that you got, and you'll still have inaccurate reaction time measurements.
Doesn't matter how fast it is.
We got a thumbs down on that.
We got a thumbs down. You can be doing this with a supercomputer if you're using a commodity grade mouse, and it will still be wrong.
Cheap monitor.
And a cheap monitor. Yeah, absolutely. So that I guess that more or less sums it up. And
yeah, we can quit talking. They're tired of us by now.
They probably stopped watching anyway.
Yeah, they're not even watching.
All right. We'll see you later.
All right. Bye.